So why do we need a theory of consciousness in the first place? And what type of theories are considered so far? A theory of consciousness is necessary to explain various experimental findings and to make predictions about unseen or difficult cases of consciousness. Some findings not easy to explain with a simple model that we considered last week was that, for example, level of activation of the neurons directly correlates with a level of attentional amplification or clarity in the consciousness and things like that. So as one example, under the dual task, we found that we saw that some aspects of the stimuli are still consciously experienced without paying attention to it. So that the face genders are something that seems to be the case, but not others, such as discs. And critically, one of the experiments that we conducted had one object that is composed of the faces, but painted with a green and red in a different way. And with attention under the single task situation, we were able to see both of them and can monitor its clarity by metacognition report. However, under the dual task situation, without attention, then face aspect still remains consciously available and metacognitively reportable. However, the other aspect, the disks, in a sense, phenomenologically becomes really unclear, and the performance-wise, it goes down to chance, and also we cannot metacognitively access. So this kind of issue, together with the attention without consciousness, that enhancing the activation through the attention, and another type of the evidence that I haven't actually reviewed, which is that under some condition, paying attention to some aspects increases more neural activity, but it leads to disappearance from consciousness and things like that. And these are a bit difficult to explain with this simplistic kind of model. Also, if you stop a bit and then think about it under this type of experiment that we discussed, it's highly common sense that we have pretty much everybody agrees that before a stimulus appears on the display, under this psychophysics experiment, we are actually conscious already of a screen and the environment and the surrounding. And then when the things actually comes up briefly, we can see it, and then there is some kind of evoked activity in the brain. Yeah, fine. But after it disappears, again, we are still conscious of the screen and also room and many things. And it's not that these extra things are random. For example, under background, thoughts or emotion and so on, that will cancel out, across all the trials. It's more like constantly, and every trial we see this, screen and background and room and so on, before and after. But under this evoked stimulus paradigm situation, it seems it's very difficult to give any explanation of why or how these conscious experience before and after is supported by the brain. So these things and the others are the kind of the cases, many cases that stimulus evokes paradigm based on theories have a hard time in explaining these. So not only these kind of things, but generally speaking, just continuing the empirical research may be difficult to sustain. And so here we are going to consider three options that we can take. One is that to commit to just empirical experiment, and then trying to be very neutral about any theories for now, because it's you might think that consciousness is too young kind of field, that it doesn't just benefit from committing to any theory, and just trying to observe and also poke around in the brain and looking at the neurons and the neural activities just enough to understand better, to bring up many of the empirical evidence to think about theories for now. And then that's one attitude, and many people actually try to take that attitude. And then the second one is to commit to a particular theory or model that can explain at least many of the empirical or experimental findings that you think is important. It may be difficult to come up with a theory or model that explains everything very well, but at least within the domain of something, for example, backward masking or continuous flash suppression or binocular rivalry, it may be possible to come up with a theory and then just commit to that theory for now and then try to extend that as much as possible. The third option that we are going to talk about this week mostly is that rather than going from this type of the approach, try to first identify essential properties of consciousness and then try to think about how these properties can be supported by a physical system. It's a very alien kind of thinking possibly for now, but I'll try to motivate it after going over the first two options. So the first theory neutral approach is that even if you encounter in some kind of difficult situation like a dual task situation or a dissociation between consciousness and attention, or display conscious awareness before and after the stimulus, we just commit to the empirical finding only. And then one of the most powerful empirical research program is the trying to identify the neural correlates of consciousness, the NCC. And this is the one that I have been kind of reviewing over the last couple of weeks. And this has been proposed by Crick and Koch in the 1990s. And then the key idea was that to find a stimulus that does not change, but it fluctuates in terms of the consciousness, such as NECA cube or binocular rivalry or backward masking at the threshold. And then try to find a subset of the neurons that correlates with the perceptual reports of this fixed stimulus set. And then the eventual kind of an ideal sort of the theoretical goal is to trying to find what kind of laws in science can explain physical words, properties such as electrochemical reaction in the brain leads to subjectivity or consciousness to the right side. Okay. And then the advantage of this approach is that it can just focus on the empirical experiments, and it has, in fact, with this kind of neutral approach, lots of findings has been already, discovered, and week 1 to 9, listed lots of, empirical findings. And then when facing the difficult cases, we can still make further progress by focusing on each sub-questions for future experiment. So, for example, every time when we have let's say this, screen-based awareness kind of situation, maybe we can fix either stimulus input or behavior output or conscious experience one at a time, and then see whether the rest of that changes or not, and then try to see whether we can exclude or identify subset of the neurons that correlates with our screen awareness or room awareness over the many trials. That's one possibility. And the disadvantage of this approach is that it's hard to digest all of the previous findings without any theoretical frameworks. Yeah, so as you already know that since 1990s, there has been lots of studies on neural base of consciousness, and then in particular neural correlates of consciousness. And it's very difficult to keep track of everything without any framework, theoretical framework, and then try to, each cases, if you have some weird phenomena or things to discuss, then you need to remember all the details to properly understand each of this. And as a result of this difficulty in explanation, it also becomes difficult to predict what's going to happen. So it's hard to provide a guidance on what's the most critical and important experiment that should be done in the future. So at least we need probably some kind of a model that explains as much as we can. That's a typical kind of attitude that many of the researchers are taking these days. because we have so many empirical findings. And one of the most powerful or popular ones is this global neural workspace theory, as we have reviewed, touched upon a bit. And the advantage of this theory is that because it starts with a relatively intuitive kind of psychological models, and together with the neuronal basis of neural correlates of consciousness empirical finding, it's relatively intuitive to understand. Okay, so like if there's an attention absent or present, maybe our activation is shrinking or expanding, and then when the stimulus is weak or sufficient or strong, it's either confined within the visual cortex or expand to a prefrontal cortex or parietal cortex. It's relatively intuitively understandable. And then with this, we saw that inattentional blindness, change blindness, attentional blink can be explained as well. It may be difficult to explain like a dual task, but maybe we can just ignore that for a moment. And then that result in this this consistent framework with lots of findings from the NCC type experiments. And importantly, at least this type of the theory can make predictions and the guidance, unlike completely theory neutral NCC approach. On the other hand, the disadvantage of this type of the model, which actually exists in many different kinds, not only the global neural workspace theory, is that first we need to select which findings to explain thoroughly, because there are too many experimental types and too many findings, and trying to come up with a single and relatively simple, understandable, intuitive model, we need to focus on some particular type of the paradigm and those experiments. And in the case of the neural global workspace theory, it's great to explain backward masking, attentional blink, and the change blindness and the inattention blindness possibly, but it can possibly also miss essential features of consciousness or what we wanted to explain in the first place. For example, can people without communication ability be still conscious? And this is a question that is probably outside of the global neural workspace theory from the first place, because they assume that consciousness is something that is only verifiable through communication. And we are going to talk about this in week 12, but if that's the case, then the theory needs to, in a sense, shut down and be kind of neutral about this type of that situation. And in fact, this study that I introduced in week 1, imagery of the person, in retrospect, it may be able to explain it, for example, based on the activation in the parietal or prefrontal cortex and so on from the global workspace theory. But what kind of experiment needs to be done, or what kind of criteria needs to be established, is unclear with this cognitive or psychological model of consciousness. And it leads to many of the problems. In fact, this is a novel or sort of the actual story of the person here, Martin, who lost complete ability to completely move his eyes and blinks and everything, so that when he was young, he was treated as basically completely unconscious, including mothers and also doctors and all other nurses. But with extraordinary training and also mental capability, he regained his muscle ability and also mental ability to become quite functional. And then he even wrote this novel a couple of years ago. So people without communication is difficult to identify, or at least to have some kind of insight with this type of theory. And also some for example newborn babies or premature babies, they of course don't have any kind of communication ability, but what do we do with these type of creatures? Can we assume that they are not conscious, because without any kind of capability to communicate with in any way, that's also hard kind of question for these type of theories that are based on just a stimulus and response kind of paradigm. So with these consideration, to come back with the initial question, aren't we conscious all the time without any stimulus or report? In fact, most of your time throughout the day, you don't really report anything about what you experienced, and also without any stimulus, such as closing the eyes or during the sleep, you can experience a highly vivid experience, such as dreaming. And if you have some kind of brain conditions, you might hallucinate. I mean, the dreaming is also one part of the hallucination kind of stuff, but can experience something without any stimulus. So stimulus input and behavioral report is not really necessary for consciousness per se. And it also doesn't explain why particular experience feels the way it is. It's a bit difficult to explain without going further what it means, but just to give you an idea, any moment of the visual experience you have is probably spatially extended, right? It's not like auditory experience where you can locate the sound, but it's not like spatially extended kind of experience, what the auditory experience is. But the visual experience is always spatially extended. Some kind of size and the location are always there. And then most of the cases it's colored, and so there is always shapes or flat, whatever. And then important thing is that all of them are coming at the same time. And blah blah blah, many features. But any kind of theory that needs to that's available to explain as much as we can tend not to deal with this type of the difficult issues. It's so fundamental. And as a result, it doesn't also tell us anything about usually that why does visual experience of this type so different from auditory experience. I mean, it is related in some way, like when I hear some particular sound, I tend to associate it with visual stimulus, or when I see visual experience, I may imagine some type of the auditory experience. But the quality-wise, it's hard to imagine that I mistake visual experience with the auditory experience. It's so different. But why it's so different is very unclear, especially now that you have already learned lots of neural correlates, and also different types of the brains, and also what's underlying all this processing. In the end, different brain areas are composed of different connections of the neurons, but the different neurons do not have a particular type of the component or essence that makes them generate auditory experience or visual experience. So it's very difficult to understand or even imagine what makes this part of the brain generate a face experience, and this part of the brain generate motion experience, and this part of the brain generates color experience. And pretty much any models that try to explain things so far is not really addressing this type of the questions. So in summary, we need the theories of consciousness, in the first place, because the field has matured enough to explain lots of, have generated lots of experimental findings that needs explanation. On the other hand, if you build a theory just to with a single and also simple model, it's almost impossible. And then as a compromise, if one tries to propose a theory that focus on a particular paradigm, let's say, let's focus on the stimulus evoked, consciousness paradigm. And then you are trying to explain why Mr. X reports seeing Y under a certain situation, then it can miss the essential features of consciousness, such as experience without any reports, or experience of different types, or why in the first place we need to explain anything. So as a third option, I briefly mentioned that there can be a situation or model or theory that can be constructed if we start from the essential features of consciousness. And what are they is the next part of the video.